Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from ISI MStat 2019, problem number 7 from the PSB section. So the problem says that suppose an SRSWOR of size n has been drawn from a population labeled 1 to up to n, where the population size capital N is unknown. Then first question, find the maximum likelihood estimated n hat of n. Second, find the probability mass function of n hat. And lastly, show that n plus 1 by n into n hat minus 1 is an unbiased estimator of n. So let us first try the first one. See, the population is this, right? This is 1 through n, and n is unknown. A sample of size n has been taken using SRSWOR, that means simple random sampling without replacement. So let xi denote the label of the ith row. Then the joint PMF of this x1 through xn, right? These are the elements of the sample x1, x2 up to x small n. So the joint distribution, these are random variables obviously because we don't know the which elements are going to be in the sample. So the joint distribution, the joint PMF of this x1 through xn is nothing but 1 by n choose n, right? Where each of the xi's are from this set. This should be capital N. This should be capital N. This one. This should be capital N. So this is the joint PMF of the entire x1 through xn, right? Now, what is the likelihood function of, since we are supposed to calculate the MLE of n, so what is the likelihood function of n? It is nothing but the joint PMF, right? Where each of the xi belongs from 1 to n, right? Now, it is 1 by n choose n, where since each of the xi has to be between 1 and n, right? So n is basically greater than or equals to the maximum of them, right? Since each of the xi belongs to the set 1, 2 up to n, right? So that means the maximum of them is also less than equals n, and hence capital N is greater than equals x order n, right? Right? So that means the function ln is nothing but 1 by n choose n if n is greater than equals x order n and 0 otherwise, right? Now, given r, suppose given r, n choose r is actually an increasing function of n. That means if we fix r, then this particular function n choose r is actually an increasing function, and we can easily prove that. Let phi of n denote n choose r. Then phi of n plus 1 is n plus 1 choose r, right? So phi of n plus 1 divided by phi of n is actually n plus 1 choose r divided by n choose r, which can be easily solved to be n plus 1 divided by n plus 1 minus r. Now r is obviously less than equals n plus 1, right? It has to be in fact less than equals n. So this entire thing is actually greater than 1. Therefore, phi of n plus 1 is actually greater than phi of n, right? So that means the function, this particular function is nothing but an increasing. If we fix r, if we fix this r, then this is an increasing function in n. That means as we keep on increasing n, the value of this entire function is actually keeping on increasing, right? It keeps on increasing. So now L of n, this likelihood function L of n is maximum when this particular term is minimum, right? This is since this is the reciprocal of this. So L of n, this entire thing is maximum when this denominator is minimum. Now this denominator is minimum. This is n choose n. Small n is fixed, right? Is the sample size. Small n is fixed. So this capital N, since entire n choose n, is this thing is actually defined if n is greater than equals x order n, right? And otherwise it is 0. So the value of n for which this is minimum is actually x order n, right? Because if it is greater than x order n, then it is actually this thing is actually is increasing, right? Right? So that means the minimum value of this thing is the L of n is maximum if n choose n is minimum, right? And hence n choose n is minimum if n is equals to x order n, right? This is the minimum value for which n is this thing is attaining its minimum value for x order n. Otherwise it is increasing as we go beyond x order n. It is actually increasing. It is an increasing function of n. So n hat is actually equal to x order n is the MLE of n. That is the largest ordered statistic, that is the largest observation in the sample, is actually the maximum likelihood estimator of n. So you have got the first answer, right? First answer to the question. Now what is the probability mass function of n hat? Now it is also quite easy to calculate. So let probability x order n is equals to t can be written as probability x order n less than equals t minus probability x order n less than equals t minus 1 can be written as like that. So this one, probability x order n less than equals t, is actually nothing but t chosen by n chosen. Why? Because this thing means that the largest sample with the largest value in the sample cannot exceed t, right? It can be at most t. Suppose the now the obviously the number of possible samples is n chosen, right? This is the number of possible samples. Now in how many of the samples are we going to have the largest value at most t? If we just restrict ourselves up to t, right? 1 2 3 up to t, if we choose the sample from 1 to t, right? If the each of the elements belongs to the 1 up to t, then the entire sample, the maximum observation in the sample, is also going to be at most t. It cannot be greater than t, right? This is the probability mass function of x. This is the, this is the function of probability of x order n less than equals t. And obviously just replacing it by t minus 1, we get for this one, right? So ultimately probability x order n is equals to t is t chosen by n chosen minus t minus 1 chosen by n chosen. That means this entire thing is probability n hat is equals to t is t chosen minus t minus 1 chosen by n chosen, where t has to be from n, small n, right? Because the minimum value, the minimum value x order n can have is actually n, right? Because the sample is of without replacement. So in any sample, the maximum value can be up to capital N, but the minimum value has to be n, right? Because the size is n. So the minimum value of the maximum value of the sample is small n. So t actually runs from small n, not up to 1, not from 1, it's from small n. So now this particular thing, t choose n minus t minus 1 choose n, can be written as this, right? Because we can use this identity, n choose r plus n choose r plus 1 is equals to n choose n plus 1 choose r plus 1, right? This we can use this, and we can say that the PMF of n hat is t minus 1 choose n minus 1 divided by n choose n. So we have also got the second answer, right? Now for the third, let us find the expectation of n hat. So expectation of n hat is nothing but summation t into probability n hat is equals to t running from small n to capital N. Now this is nothing but t into t minus 1 choose n minus 1 divided by n choose n. Now this thing, adjusting this thing, multiplying n here and n here, this entire thing can be written as summation t choose n, t running from n to n, capital N. Now by the hockey stick identity, summation t choose n running from n to capital N is actually nothing but n plus 1 choose n plus 1. Now you might think, what is this hockey stick identity? This is actually a very easy to prove identity. It basically says that, you know if you add the coefficients of x to the n of, if the coefficient of x to the n in the expansion of 1 plus x whole to the n plus 1 plus x whole to the n plus 1 and so on. It is basically, I am giving you a hint to solve this particular thing, this prove this hockey stick identity. It is very easy to prove. Just write it down explicitly and think of it as the coefficient of x to the n in the expansion of something, in the expansion of 1 plus x whole to the n plus 1 plus x whole to the n plus 1 and so on. Try to do that. It's very interesting. Now for this, using this hockey stick identity, this entire thing is nothing but n plus 1 choose n plus 1. Therefore ultimately the expectation of n hat is nothing but n by n plus 1 into capital N plus 1. Therefore expectation of this thing, n plus 1 by n into n hat minus 1, is equals to n. Therefore this is nothing but an unbiased estimator of capital N. Therefore we have also proved the third question, right? So this was a very easy problem. The only thing you needed was a basic understanding of how the sample server works. That's it. The SRSWOR. That's it. Very easy. So there you have the solution. See you till next time.